In 1943, the British government made a film about a factory in Bridgeport, Connecticut. The film follows a shipment of machines across the Atlantic through a U-boat attack because Allied tank production could not move without them. For most of a century, machinists around the world did not call these machines vertical turret lathes. They just called them Bullards. But the company behind the name would be swallowed whole, dragged through federal court, and torn down. Today, the site sells bulk groceries. Before the story begins, this is Trade Archive, where the machines that built the modern world finally get their stories told. If that is the kind of history you want in your feed, take a moment to like this video and subscribe. Now, back to Bridgeport. So, how did a lathe become a household name on every shop floor in America? It started in Uxbridge, Massachusetts in 1841 with the birth of Edward Payson Bullard. Company lore says he was orphaned young, put to work on a farm, and walked to Hartford, Connecticut, looking for a trade. The documented record picks him up as an apprentice machinist at the Whitney Machine Works, learning to cut iron in the heart of New England's textile machinery country. From there, he moved to Colt's Armory in Hartford, where the Civil War kept the shop floor running flat out, turning out revolvers for the Union, and by late 1863, he was at Pratt Whitney, the firm that would come to define American precision. Colt taught him production. Pratt Whitney taught him accuracy. Between them, the two most demanding shops in America gave a farm boy from Uxbridge a complete education in metal, and in April 1865, with the war ending, the 23-year-old struck out on his own. And then he failed, repeatedly, and for 15 years. His first venture, Bullard & Prest, set up in Hartford's old county jail building, making vertical drill presses and pumps. A partner named William Parsons came aboard. Prest walked away, and the firm became Bullard & Parsons. One of those early drill presses was still earning its keep in the Bullard Works 4 decades later, which tells you the product was never the problem. The money was. The Depression of 1868 strangled the firm's capital, so Bullard reorganized in Bristol, Connecticut, bought a foundry, ran it for barely a year, and dissolved the whole thing. He went south to superintend a machine shop in Athens, Georgia, and resigned when the town made it plain that a Yankee boss wasn't welcome so soon after the war. He landed in Cincinnati selling second-hand machinery, and his first sale there tells you everything about the man's eye for iron. He found a set of Lincoln milling machines rusting in an abandoned Confederate arsenal in Georgia, and turned dead stock from a dead cause into working capital. From there, he became general superintendent of the Gill Car Works in Columbus, Ohio, where his son, Edward Payson Bullard Sr., was born in July of 1872. Then, the Panic of 1873 took that job too. A stint at an engine works in Mount Vernon followed, then a machinery store on Beekman Street in New York, then a partnership at 14 Day Street that lasted about a year before his partner pulled out. 15 years of work, and what did he have to show for it? A dissolved partnership, a sold foundry, a resignation in Georgia, a panic that ate his job, and a series of storefronts in Manhattan with other men's names beside his own on the door. By 1880, Edward Bullard was 39 years old, a man who had watched one venture after another die under him, and who understood the machinery business from every possible angle because he had been bruised by most of them. He knew how iron was poured, how machines were built, how they were sold, and how quickly a good product could be buried by bad financing. So when he finally planted a flag, he planted it carefully. That flag went up in Bridgeport, Connecticut. In 1880, Bullard contracted a local builder named A.D. Laws to manufacture lathes to his own design, agreeing to take the plant's entire output. The arrangement had problems, so Bullard did what he always did. He took the operation over himself, named it the Bridgeport Machine Tool Works, and opened for business on August 20, 1880, in a rented loft on Broad Street. The first product off the floor was an ordinary engine lathe. There was nothing ordinary about what came next. Every heavy shop in America shared the same miserable problem. To machine a large casting on a lathe, you had to bolt it to a vertical faceplate, which meant fighting gravity the entire time. A crane held the piece while men wrestled it into position, shimmied it, clamped it, and prayed it didn't shift under the cut. A single heavy wheel or gear blank could tie up a crane, a gang of men, and half a day of shop time before a tool ever touched metal. Bullard's answer, in 1883, was almost insultingly simple. He stood the lathe on its end. The faceplate became a horizontal table. Now the crane lowered the casting straight down, gravity seated the work instead of fighting it, and the piece sat as stable as a stone on the ground. To be precise about the history, vertical boring mills existed before Bullard. What did not exist was a small, accurate one. The historian Joseph Wickham Rowe wrote in 1916 that boring machines until then were relied on only for large and rough work. Bullard's first machine, a 37-inch mill sold to a Brooklyn paint machinery maker named George A. Young, brought lathe precision to a class of work that had never known it. The business grew on the strength of that one idea. A second cutting head was added, capacity climbed to 51 inches, and by 1889, Bullard dropped his New York interests entirely to focus on Bridgeport. On September 4, 1894, the firm incorporated as the Bullard Machine Tool Company, its stock held entirely by Bullard and his sons. He had married Alice Martha Camp back in 1865, and the couple raised a large family, several of their 11 children lost in infancy, the surviving sons raised practically on the shop floor. When Edward Payson Bullard Sr. died of heart trouble in Bradenton, Florida, on December 22, 1906, the trade press remembered a practical philosopher who did his own thinking and was never afraid to take an advanced step because no other had taken it. It reads like a eulogy. It also reads like a product roadmap, because his son was about to take the biggest advanced step in the company's history. Edward Payson. Bullard Jr. had been vice president since the 1894 incorporation, educated at Williston Seminary and Amherst College, and steeped in the works since boyhood. In 1900, he represented the firm at the Paris Exposition, and what he saw there redirected the entire company. The French were building automobiles, and automobiles meant something new in manufacturing. Thousands of identical round parts, hubs, gears, flywheels, each needing several operations, and each operation traditionally requiring its own setup on its own machine. Standing in Paris, Bullard Jr. sketched out a machine that fused his father's vertical boring mill with the turret lathe. A rotating, multi-sided turret head above the horizontal table, a different tool on each face. One setup, one machine, one operator. The vertical turret. Lathe went into production around 1902, and it became the architecture the entire industry copied. In 1911, the company added a 5-position indexing turret accurate to 1/4 of an inch. And the new era line that followed, the machine's old hands called kicker Bullards for their foot lever engagement, carried the design through the mid-1920s. Bridgeport did not own this market unchallenged. Niles Beaumont Pond, King Machine Tool, and Giddings and Lewis all built heavy vertical machines. Across the Atlantic, Webster and Bennett in England and Schiess in Germany were building to standards of their own. What separated Bullard was that it never stood still. By the time a rival had matched the current machine, Bridgeport had already drawn the next one, and the trademark became so completely identified with the firm that it dissolved into the language itself. On shop floors from Detroit to Glasgow, a vertical turret lathe was simply a Bullard, whoever built it. Ask an old machinist to go run the Bullard, and he might walk you straight to a machine wearing another maker's nameplate. Very few companies in industrial history ever reached that point. Bullard got there before the First World War. But Bullard Jr. was already looking past his own invention because he had seen where the automobile was headed, and no single spindle machine on earth could feed that appetite. His answer arrived in 1914, and it was less a machine than a system. The multi-omatic. Picture a massive central column carrying a ring of vertical spindles, commonly 6 of them, each spindle a workstation with its own dedicated tooling. An operator loads a rough casting at the first station. The machine indexes. At every station around the ring, a different operation runs simultaneously on a different part, drilling here, boring there, facing, finishing. The old logic of the shop was that a faster machine made one cut faster. The multi-omatic collapsed an entire lathe department into a single machine, and with every index of the great column, a finished part came off the ring. Bullard's engineers demonstrated to Henry Ford himself how quickly the machine could turn out a Model T flywheel, and the machines went into Ford's operations, into Buick, into Chevrolet, into Clark Equipment, into the supplier plants feeding Detroit. If you drove an American car in the 1920s, you rode on parts that came off a Bullard. Yet inside that triumph sat a quiet threat, and every machinist in America could feel it. Before the multi-omatic, cutting metal was a craft. A skilled man served years of apprenticeship to learn it, calculated his own feeds and speeds, measured, adjusted, and coaxed the cut, and his judgment was the difference between a part and a piece of scrap. The multi-omatic paced itself with synchronized cams and gears. The sequence was ground into steel before the machine ever left Bridgeport. The intelligence lived in the machine and in the engineers who set it up, and the worker's job shrank to loading castings and pulling a lever. Labor historians call it dilution. The craft unions, above all the International Association of Machinists, understood it as an existential problem, because a machine that runs itself does not need a man with a 5-year apprenticeship standing in front of it. Bullard had built one of the finest tools of the century, and in the same stroke helped move control of the factory floor from the man at the machine to the men in the office. That tension was about to detonate in the company's own hometown. When the First World War broke out in Europe, Bridgeport became one of the great munitions boomtowns of America. The city's population surged from roughly 102,000 in 1910 toward 143,000 by 1920, swollen with immigrant workers from Poland, Scandinavia, Hungary, and Italy, and the New York Times took to calling Bridgeport an American Essen after Germany's great armed city. Housing collapsed under the strain, with workers sleeping in shifts in rented rooms, and the crisis grew severe enough that the federal government's United States Housing Corporation eventually broke ground on Seaside Village in the South End, where about 257 brick homes went up before the armistice halted construction, built for no other reason than to shelter the city's war workers. And in the summer of 1915, the pressure blew. The 8-hour-day movement swept Bridgeport, starting with the building trades that spring and spreading to the machinists at Remington's enormous munitions works and across the city's metal shops. Employers with rush contracts and no time to lose found they had almost no leverage, and the strikers largely won. When thousands of women from the cartridge plants walked out that August, the movement became irresistible. The Machinists' Union was so encouraged by what happened in Bridgeport that it took the 8-hour fight national the following year. Bullard's operation sat in the middle of this storm, a family firm run by old Yankee stock in a city that was increasingly organized, increasingly immigrant, and increasingly radical. As the war wound down, the company moved into a sprawling new plant out on the Bridgeport and Fairfield line, in the Black Rock section, the works that would define it for the rest of its life. The 1920s rewarded them. Railroads, trucks, and the booming auto industry consumed vertical turning capacity as fast as Bridgeport could pour it, and in 1927, the company replaced the new era with the spiral drive, its table driven through a Gleason spiral bevel gear that turned the old machine's racket into a hum. Then, On January 4, 1929, the family took the step every private dynasty eventually faces. The firm renamed itself the Bullard Company, and its stock went public on the New York Stock Exchange. 9 months later, Wall Street collapsed. But a nation cannot maintain railroads or build trucks without vertical boring mills, and the company that made the standard of the breed survived a depression that killed plenty of its neighbors. Through the 1930s, it sharpened its edge. The Cutmaster series arrived late in the decade, engineered from the ground up for the new tungsten carbide cutting tools, with table speeds running from a crawl of just over 3 revolutions per minute up to 240, driven by 30 horsepower motors, a heavier, faster, more rigid machine for an era that did not yet know how badly it would need one. In 1937, the American Society of Mechanical Engineers awarded Bullard Jr. its medal, and that same year, the company bought itself a locomotive. A tiny H.K. Porter saddle tank switcher, oil-fired, riding on 26-inch drivers, barely larger than an automobile, that spent its days shuffling flat cars of castings and finished machines around the Bridgeport yard under the name Bullard Company No. 2. Remember that little engine? Then came the Second World War, and with it, the hard truth of industrial mobilization. America could not build a tank, a bomber, or a battleship until it first built the machines that cut their gears, bored their turret rings, and turned their gun mounts. Machine tools were the bottleneck of the entire arsenal, and vertical turning was Bullard's kingdom. By 1942, the company employed more than 2,000 people and ranked as the third largest machine tool builder in the United States by workforce, behind only Cincinnati Milling Machine and Brown and Sharp, and within its own specialty, it had no serious rival. Cutmasters shipped to shipyards, ordnance plants, and aircraft factories in numbers the builder would eventually count in the tens of thousands across the series' life. A 1941 trade advertisement pitched the machine to railroad men as a modern tool designed to put shop schedules on par with train schedules. The railroads bought it. So did nearly everyone else with heavy metal to turn. The Allies noticed. In 1943, Britain's Ministry of Supply and Ministry of War Transport produced We Sail at Midnight, a propaganda film built on a single premise. A new British tank cannot go into production without special machine tools, and those tools exist in exactly one place, the Bullard plant in Bridgeport, Connecticut. In the film, trucks roll out of the factory gates through a Connecticut winter. The machines are loaded aboard a freighter under a midnight sailing deadline. The convoy fights through a U-boat attack, and Bullard Multomatics are bolted down in an English works to cut the tank's gears. John Ford, the Hollywood director, worked on the picture without credit. Strip away the drama, and the message to the British public was blunt. The tools of victory come from Bridgeport. It is worth pausing on what it actually took to build one of these machines, because a Bullard was not so much assembled as grown. The company ran its own foundry on the property, proud enough of it to print brochures and walk the public through it. Molten gray iron went into enormous sand molds and came out as beds, columns, and tables that dwarfed the men who poured them. A 36-inch Cutmaster, the small end of the line, shipped at around 31,000 pounds, and the big rail and turbine machines ran far heavier. All that iron was not excess. It was the entire point, because mass soaks up vibration, and a cutting tool that does not chatter holds its line. The rough castings then had to be machined, and the machines that did the heavy work of turning Bullard tables and boring Bullard columns were, of course, Bullards. Gears were cut and hardened in-house. The cams that gave a Mult-O-Matic its rhythm were profiled to the thousandth, because a cam that lied about its timing would wreck 100 parts before anyone noticed. And then came the part that no machine could do. The sliding surfaces, the ways, were finished by hand scraping. a fitter with a hand scraper and a reference plate, shaving off high spots a few 10,000ths of an inch at a time, checking the bearing pattern in blue dye, again and again, until the surfaces mated with an accuracy no production grinder of the era could deliver. On the biggest machines, men climbed up and stood on the chuck itself just to reach the rails. Running one was its own education. Machinists who lived with the cut master describe it as one of the more dangerous machines in a shop, a rotating table strong enough to throw a man, worked by people who learned never to wear loose clothing anywhere near it, and who came to love it anyway for what it could do. It was patient, punishing, exacting work to build and to run. It is also the reason those castings still cut straight today. But we will get to that. The war ended, and the company kept its crown for a while. Bullard Jr. stepped down after roughly 40 years in the president's chair and died in June of 1953. Decades later, he would be elected to the Machine Tool Hall of Fame at the American Precision Museum. By 1955, the plant on the Fairfield line covered 52 acres and more than 1 million square feet of floor space, with a workforce of about 2,000, and the company was pushing into the electronic age. It installed electronic production control in its own operations that year. Pendant controls appeared on the Manow-Troll line, and punched tape numerical control arrived on the Dynatrol. Machines offered from 26 inches of swing all the way out to 144. The Continu-Matic and the Maxi-Mill handled the continuous heavy work that railroads and truck builders needed, and the company acquired the Universal Boring Machine Company to add horizontal machines to the catalog. Locomotive wheels, transmission gears, turret rings, gun mounts, and eventually the great forged discs at the heart of a jet engine. If a part was round, heavy, and had to be right, it had almost certainly spent time on a Bullard table. A century after the founding, men named Bullard still sat among the company's officers, and a descendant named David E. Bullard would be the last of the family connected to the firm, the man whose saved papers now fill an archive in the Bridgeport Library. From the outside, it all looked eternal. It was not. By the late 1960s, the economics underneath the American machine tool industry were shifting. Numerical control demanded capital on a scale family firms struggled to raise. Foreign builders were learning fast, and Wall Street had produced a new kind of predator, the conglomerate. In Cleveland sat White Consolidated Industries, a company that had grown out of White sewing machines and turned acquisition into an industrial strategy, swallowing no fewer than 10 companies in about 5 years. Its sales ran to roughly $825 million by 1968, the year it took Knox, a foundry and mill machinery maker doing $200 million a year on its own, and bought nearly a third of the mighty Allis-Chalmers out from under its board. Somewhere in that feeding frenzy, White Consolidated absorbed the Bullard Company. There was no siege and no last stand, which is what makes it land so cold. The proud, independent tool builder from Bridgeport, the firm once run by mechanics who walked their own foundry floor, simply became a line item in a Cleveland portfolio, its fate decided by men who had never stood on a chuck in their lives. The courts noticed before the public did. Allis-Chalmers fought White's advances all the way to the federal appeals bench in 1969, in litigation that laid the conglomerate's acquisition machine out in the open for anyone who cared to read it. In 1971, a federal court in Ohio blocked White's attempted merger with White Motor on antitrust grounds, a defeat that ultimately cost the company tens of millions to unwind. And in the Justice Department's antitrust case against Cleveland Trust, the government's own filings named the Bullard Company for what it had become, a White Consolidated subsidiary selling vertical boring mills, tangled in the interlocking directorates of Cleveland banking. Read those court documents, and you can watch the transformation happen on paper. Bullard is no longer the protagonist of anything. It is an asset, cited as evidence in other men's wars. What followed was the slow arithmetic of decline. Through the 1970s, the consolidations and layoffs came in waves, while Japanese and German builders flooded the market with CNC machines that were cheaper, lighter, faster to program, and computer-controlled from birth. A buyer comparing quotes did not care that a Bridgeport casting would still be holding tolerance in the next century. He cared what it cost this quarter. The great cast iron works on the Fairfield line bled orders year after year. For generations in Bridgeport's working neighborhoods, a job at Bullard had been close to hereditary. Fathers trained their sons on the same floor where their own fathers had trained them, and a man could measure his whole life in the machines he had built. Now, men in their 50s and 60s, machinists who had given the company their working lives and a fair share of their hearing along with it, walked out the gate knowing there was no floor left to train anyone on. By the early 1980s, it was over. The plant closed, and in 1983, the demolition crews arrived at the works on the Fairfield line. There was no ceremony, no plaque, no pause. The buildings that had armed the Allies came down the way any obsolete industrial carcass comes down, floor by floor, wall by wall. The rubble trucked away between morning and quitting time until the skyline that had defined a neighborhood for 60 years simply was not there anymore. Men who had spent their lives inside those walls drove past the fences and watched it happen, and there is a particular cruelty in the speed of it. 60 years to build a reputation the whole trade could recite. A few weeks to remove the evidence. Bridgeport absorbed the loss the way it had absorbed the others, because Bullard was not the only name to go. The city the New York Times once called an American Essen spent the 1980s watching its arsenal empty out, one demolished plant at a time, and the men who had made it famous scattered into whatever work was left. One structure survived the wrecking ball, the foundry, the room where all of that iron had been poured. In 1990, developers renovated it into a retail complex and, in a gesture somewhere between tribute and taxidermy, named it Bullard Square. Today, it holds a BJ's wholesale club and a multiplex cinema. The floor where fitters once scraped ways to a few 10,000ths of an inch now moves paper towels by the pallet, and the only trace of the name that armed 2 world wars is on the shopping center sign. The name itself refused to die that easily, though what followed was less a second act than a long probate fight. The machine tool line passed into a merged company called Bullard, which went public in 1990, and the last machine ever to carry the Bullard nameplate had already been built the year before, in 1989. 10 years later, the reckoning arrived. On July 15, 1999, Bullard filed for Chapter 11. Bankruptcy protection, listing $118 million in assets against $107 million in liabilities. Read that again. On paper, the company was solvent, and it was dying anyway, starved of the working capital to keep its own doors open. In 2000, it was sold out of bankruptcy court to the private equity firm KPS in an asset deal worth roughly $31 million, and rechristened Bullard II. A name with the ring of a monarchy that already suspects how the dynasty ends. It did. In 2004, the successor filed for Chapter 11 again, and this time, nobody pretended otherwise. Management called it an orderly liquidation, with sales of about $24 million in its final 11 months against liabilities that outweighed its assets by more than $22 million. 2 bankruptcies, 1 buyout, and 124 years after a failed machinery dealer rented a loft on Broad Street, the estate of the Bullard Company went on the block for good. And this is where the story does something almost no Rust Belt story does. It turns. In Rockford, Illinois, a machine tool builder and rebuilder named Bourne & Koch stepped into the 2004 bankruptcy sale and bought the Bullard assets outright that fall. Not the buildings, because there were no buildings left to buy. The drawings. Every engineering print, every schematic, every patent the Bridgeport engineers had ever produced, and the firm states plainly that it holds prints for every single part Bullard's engineers ever designed. With that archive, Bourne & Koch did something better than mourn the brand. It put Bullard's back to work. Because here is the payoff to all that foundry pride and hand-scraping. The castings poured in Bridgeport in the 1940s and 1950s are so massive, so stable, and so thoroughly stress-relieved by decades of running that they make better bones for a precision machine than most new construction. So Bourne & Koch strips a vintage Cutmaster or Dynatrol down to its bare casting, replaces every worn component to the original prints, hand scrapes the ways back to their original alignments exactly as Bridgeport's fitters once did, and then grafts on modern CNC controls, servo drives, and safety systems. The reborn machines go out to oil and gas outfits, aerospace shops, and railway plants. Somewhere right now, iron poured by men who have been dead for half a century is holding tolerance under a computer's command, and a big Bullard taking a heavy roughing cut will still fill a chip bin faster than the man running it can quite believe. The museums keep the rest of the memory. At the Steamtown National Historic Site in Scranton, Pennsylvania, the locomotive shop still runs an operational Bullard lathe on real repair work. And in the summer of 2025, the park unveiled a freshly restored little saddle tank switcher on its turntable, an engine so small that visitors smile when they see it beside the mainline giants. It is Bullard Company No. 2, the same tiny porter that spent its working life dragging castings around the Bridgeport yard before it was sold off in the early 1960s and found its way into the great Steamtown collection. The factory it served has been a parking lot for 40 years. The shop engine made it into a national park. So, what does the Bullard story finally add up to? Weigh it out. A man fails for 15 straight years, stands a lathe on its end, and gives heavy industry its footing. His son watches Paris fall in love with the automobile, and answers with the vertical turret lathe and the Multomatic. Machines that made mass production possible and made the craftsman negotiable, both in the same stroke. The company arms 2 world wars, rises to 3rd largest tool builder in America, and first name in vertical turning, so dominant that its trademark dissolves into the working language of an entire trade. And then it is eaten. Not beaten by a better machine, but digested by a balance sheet. Litigated over in federal courtrooms, liquidated twice, and demolished, until all that remains standing is a shopping center sign, a museum locomotive, and the machines themselves. The company was mortal. The iron was not. Bullard's real monument is not in Bridgeport at all. It is spinning in a shop somewhere tonight, holding half a thousandth, 80 years after the men who scraped its ways clocked out for the last time. If you want more stories like this one, about the machines that built the modern world and the people who paid the price for them, subscribe to Trade Archive. There is a lot more iron where this came from.